Quick, graph y equals the cosine of x plus 2 by hand 2 different ways. This is part of the family of functions series. You will need paper and a straight edge. We suggest you create grids similar to the ones at the right as needed. Press pause as needed anytime during the video. The first way is with the Cosine Dance. Recall the graph y equals the cosine of x, the wave there. Note the 5 key points of interest. These key points are affected by the parameters in the equation, namely the plus 2, that's a parameter in the equation. That plus 2 shifts all points up 2 units. Starting with the initial point, which is normally at 0, 1, a max, it is shifted up 2 units to 0, 3. So let's go ahead and plot 0, 3. The end of the first period normally is at 2 pi 1, a max, but it shifted up 2 to 2 pi 3, so let's plot 2 pi comma 3. Halfway between the start of the period and the end of the period is a minimum at pi negative 1, but we're going to shift that up 2 to pi positive 1, so let's plot that one. Halfway between the max and min is a point of inflection, normally at pi over 2, 0, but it's shifted up 2 to pi over 2, comma 2. So we'll plot that. And halfway between the min and the max point is a point of inflection at 3 pi over 2, comma 0, and it's shifted up 2 to 3 pi over 2, comma 2. We'll plot that. Pause is needed. We'll connect the points as a cosine wave, half of a frown, a whole smile, the other half of a frown, okay, concave down, concave up, concave down. This is only one period of the cosine wave. Let's duplicate the wave in the negative direction. We'll do that by going back the period 2 pi to negative 2 pi, comma 3. This point will go back a period also of 2 pi. The minimum goes back 2 pi. And that second point of inflection goes back 2 pi. We'll connect those points as a cosine wave. Concave down, concave up, concave down. So here's our nice, beautiful looking cosine wave here. And let's draw the line containing the points of inflection. So let's go ahead and do that. What is its equation? Pause is needed to answer that. And the equation is y equals 2. And where does that 2 come from? How about there? We'll compare it to the parent function y equals the cosine of x in blue here. And you can see that going from blue to green, that point is shifted up 2, that point is shifted up 2, that one is. In fact, all points are shifted up 2 units. Or sometimes we say it's translated up 2 units. Pause is needed. The second way is graphing this is with a table. So we'll start with our table of values that have the axes values, and I'd like you to go ahead and complete the table. Pause to do so. Putting in those values from the axes. We'd like you to create a second table. We'll do that one in green. And the only parameter we have is that plus 2, and that adds 2 to each y coordinate only. The x coordinates stay the same, so we'll keep those exactly the same. But we're going to add 2 to each y coordinate. So 1 plus 2 is 3. And so the ordered pair is 0, 3, and we'll plot that. The next y coordinate, 0 plus 2 is 2. And plot y pi over 2, comma 2. Negative 1 plus 2 is 1, pi, comma 1, and so on. 0 plus 2, 3 pi over 2, comma 2. And 1 plus 2 is 3, and back to 2 pi, 3, a max again. Connect the points as a cosine wave. Frown, smile, frown. And we'll plot another one to the left by going back a period, 2 pi, from each of the points of interest. That point of inflection goes there, the minimum goes there, and the other point of inflection goes back 2 pi to that one. Connect the points as another cosine wave. And you can see that when we compare it to the parent function, the entire parent function is shifted up 2 units or translated up 2 units, every single point. Now you try one. Graph y equals the cosine of x plus 3 using either method or both for the practice. Pause as needed, resume when you're finished. And here are your answers. You can see in green is the y equals the cosine of x plus 3 compared to the blue parent function, and every single point is shifted up or translated up 3 units.